So we're going to use and apply trig ratios when it comes to understanding angles of elevation and angles of depression. An angle of elevation is the angle above horizontal. So horizontal is running flat, right? Left and right. Horizontal is flat. The angle of elevation is the angle above horizontal from the horizontal up to spot a target. I'm going to look up at the top of the building. The measure I have to rotate my head to look at the top of the building, something above me, is called the angle of elevation. What does elevation mean, just as a word? How high up? How high do you have to rotate your head to look up at something above you? That's the angle of elevation. You think angle of elevation, when you think angle of elevation, think above. Angle of depression is just the opposite. An angle of depression is defined to be the angle below horizontal. So if I have the horizontal running left and right like this, I look down at my feet, the angle that I rotate from the horizontal down to look at my feet is called the angle of depression. When you see angle of depression, think below. I'm looking down at something. I'm rotating under the horizontal. Now, my hometown, in Indianola, every summer we have the Balloon Classic. About a week and a half, 2 weeks, there are hot air balloons up in the sky, right? And that's a good circumstance of angles of elevation and angles of depression. Say there's a hot air balloon up in the sky. I'm on the ground looking up at it, flying ahead of me. The angle of elevation from the horizontal running left and right, from the horizontal up to look at the balloon, that's the angle of elevation. That labeled angle in blue is the angle of elevation from the person up to the balloon. And let's just come over here and reverse that. Find an angle of depression. From the balloon back down to the target on the ground, that's called an angle of depression. It's called an angle of depression. What angle measure does the balloon have to look to spot a person or target on the ground? So from their horizontal down to the surface, that's an angle of depression. Is there anything important about those two angle measures that I've labeled in blue? Those two angle measures in blue, is there anything important about those two angle measures that I can assume? Second time? They are the same. And that should make sense. The angle measure that I have to look up at the balloon at will be the same angle measure they have to look down to me from. The angle of elevation from the person to the balloon is the same as the angle of depression from the balloon back down to the person. Angle of elevation is the same as the angle of depression. They're both alternate. So let's put a couple of these into practice from the examples over on the other side of the board. Description given in the question. You have to draw your own picture and write an equation using sine, cosine. Child is flying a kite being let out by 50 feet string. There's a small child flying a kite in the air. The angle of elevation From the ground up to the kite is 27 degrees. What's the height of the kite? We'll do this one more time, and let's underline what's important. That's always a good strategy. A 4-foot tall child. So I'm going to draw a stick figure here to represent this person. They are 4 feet tall. They are flying a kite up in the sky that's being let out by 50 feet of string. The kite is attached to the person by 50 feet of string. The So let's add a horizontal line and put our 27-degree angle measure as the angle above horizontal. Up to the kite, it's 27-degree angle. Does that make sense? Got our 27-degree angle measure. What's the height of the kite? So from the kite down, what is that distance? Yeah.
Why does the height of the child matter?
We'll talk about that in a minute. Let's find this missing link first. Based off of this triangle, I'm going to use SOHCAHTOA to find that missing link, the height of the kite above the person. Would I use sine, cosine, or tangent? Yeah, what do you think? This 50 feet, is that the opposite, the adjacent, or the hypotenuse? And this side labeled x, the height of the kite, that would be which side? Opposite or adjacent? Opposite. So opposite to hypotenuse is which trig ratio? Sine. I've got SOHCAHTOA written up on the board here. So opposite to hypotenuse, x to 50, that's the same as the sine of 27 degrees. There's our proportion. Sine of 50 degrees, sine of 27 degrees equals x over 50. Put this over 1 and start cross multiplying. So x times 1, that's equal to the other cross product of 50 times sine 27. Go to your calculator. Let's type that in. 50 times the sine of 27 degrees is about 22.7. What would that be labeled in? Units of what? Feet. Okay. Trying to find the height of the kite. So this goes back to Treston's question. Why would the height of the person matter? We're trying to find the height of the kite off the ground. Is it 22.7 feet off the ground? Oh, what else do I have to do? Second text.
Where's the child?
Person up to the kite, that's 22.7 feet. I want the height off the ground, so I need to go from the ground up to the person by adding another 4 feet. This side length is just the kite down to the person down to the surface. Add on 4 more. height of the kite is in two different pieces, from the surface up to the person. The kite off the ground. All right. It's a good angle relation question. Let's try one more. All right. On the right part of the board, a park ranger in a 150 meter tall observation tower spots a forest fire at a 3-degree in terms of a right triangle. Let's read through this one more time and start drawing a picture to match the information. A park ranger is in a 150 meter tall observation tower. And they spot a fire, so there's a fire over here, at a 3-degree angle of depression. An angle of depression is the angle down, right? Below horizontal. So from the forest, from the observation tower, from the park ranger, there's a 3-degree angle of depression from the top of the tower down to the fire. Angle of depression. How far from the tower is the forest fire? Distance is measured horizontally, from left to right, from tower to fire. How far away? How far from the tower is the fire? So I've got that side length labeled X, left for us to find. Questions so far on getting this set up. That's not 3 degrees. 3 degrees is right below the horizontal. That leads to my next question. I have a 3-degree angle of depression. That's not 3 degrees right here. It's 3 degrees right below the horizontal. But I can move the 3 degrees somewhere else. Which angle measures 3 degrees? On top or bottom within the figure? This is 3 degrees as the angle of elevation from the fire up to the tower. The angle of depression from tower to fire what would this have to be? Why 87?
Because there's a right angle on the bottom and all adds up to 180.
Right, so there's a right angle right here. Don't these two also have to make 90 as well? It's a corner here as well. What plus 3 degrees makes the 90 I need? Another 87 right below. Let's just use this. Is that the opposite leg, the adjacent leg of the hypotenuse for my 3-degree label here? I think I'm given the 150 meter height of the tower. Is that opposite or hypotenuse from the 3-degree label here? Opposite, good. Trig ratio. Think about sine, cosine, tangents. What do you say next? Sine, cosine, or tangent? A second to go. The tangent of 3 degrees equals what to what? Which proportion? 150 over x or x over 150?
50 over X.
50 over x, opposite to adjacent. All right, let's cross multiply again. So my two cross products, x and tangent 3, equal to 1 in 150. I need to solve x times tangent 3 degrees equal to 100. Three to solve. So on your calculator, there's what you type in. 150 divided by the tangent of 3 degrees. I get about 2,862.2 what? Meters. 2,862 meters away. What would that be in kilometers? How many meters are there per kilometer?
2.8622.
So roughly 2.8 or 2.9 kilometers.
Mm-hmm.
Just under 3 kilometers away is the fire pump tower. Picture, picture, picture. It's all about drawing a picture. Got to match the picture to your question. Let me pass this out, and I want you guys to try one of these on here. The rest of the day, I'll have you guys work on some practice off of here, or if you're a little bit behind on Khan and want to spend some time working on there, that'd be fine too. Before you get your laptops out, could you try question 3 off of this document? Let's just take a minute and make sure we kind of know how to handle these angles of elevation and depression questions. Got to get good at these for our test on Thursday. I had number 3 in mind as you're looking off of this practice handout. So up on the television screen, number 3, reading this out loud. Think about how you're going to draw the picture like we practiced with those two up on the board. From a point on the ground, 12 feet from the base of a flagpole, a measured angle of elevation to the top of the pole is 53 degrees. How tall is the pole? Standing 12 feet away from a flagpole, the measured angle elevation to the top is 53 degrees. What's the height of the pole? Try and draw a picture to match that question and use SOHCAHTOA to find the missing distance, missing height of the pole. Pole is the horizontal distance. And the angle elevation is above the horizontal, so we should put that down. Draw your picture on here. Where's the 12 going to be? horizontally. From person to pole, that's 12 this way. Degree is the angle of elevation. That's above the horizontal. Which side length is the height of the pole? Does that make sense? So very certain. 53 degrees is actually the angle of elevation is the angle above horizontal. So you have your horizontal running left and right. Above that is the 53 degree measured angle of elevation. Switch those. Does that make sense? Again, guys, last half of class is mostly yours. If you want to grind on Khan or continue on the practice document that you've got pulled up, that would be fine. Number 3 should be 15.9. I've got the answers for your handout up on the television screen.